Now, recognizing the patterns for sequences is the most challenging part of this unit. Suppose I want to find a sequence whose first 5 terms are given by 2 over 1, 4 over 3, 8 over 5, 16 over 7, 32 over 9, and then determine whether it converges or diverges. Well, it's hard for me to tell initially what it is. I need to get out here and I need to look and see what sort of patterns I see. Well, let's just look at the numerators. And this helps if you put what the n term is. 1, 2, 3, 4, and 5. So first I'm just going to look at the numerators. And I can see that the numerators 2, 4, 8, 16, 32, etc. These are looking like 2 to the n. 2 to the 1, 2 to the 2, 2 to the cubed, 2 to the 4th, and 2 to the 5th, etc. Okay, so this is my numerator. Now let me look at my denominator. The denominator is 1, 3, 5, 7, 9. Okay, these are odd numbers, all right? And we know we can represent odd numbers as 2n minus 1. So I'm going to check when n is 1. This is 1, 2, okay. Had this started with 3, it would be 2n. Or, excuse me, had it started with 5, it would be 2n plus 1. So this is the denominator. So I can rewrite my sequence as 2 to the n divided by 2n minus 1. Now, I found the nth term. This is a sub n. Now, does it converge or diverge? Well, let me go and say that f of x is 2 to the x divided by 2x minus 1. I'm going to do this so I can use L'Hopital. So if I do the limit as n approaches infinity of this, probably shouldn't have used an f there, should I? Well, using L'Hopital, I can see that this is the same thing as the limit as n approaches infinity of the natural log of 2 times 2 to the x divided by 2, which is infinity. So this limit diverges. Okay, because this diverges, therefore the limit as n approaches infinity of a sub n is also infinity. So this sequence diverges. Now let's look at a series of these. You can't really guess based on the first 1 or 2 necessarily whether a sequence converges or diverges. Usually you have to go a little bit further out. So if we look at a sub n, we can see that it is 1 over 2 to the n, and the limit as n approaches infinity of a sub n is 0. While if we look at b sub n, the limit as n approaches infinity of b sub n, that is also 0. But they're getting there in very different ways. Well, if I look at the limit as n approaches infinity of c sub n, it also converges, but it's going to converge to 1/9. And now let's look at the limit as n approaches infinity of d sub n. Now we're going to see the highest power in the numerator is a cubed, highest power in the denominator is a square. So there are a number of tricks we could use, but this one diverges. This limit is infinity. So we need to use inductive reasoning to see if we can figure out what the nth term of the sequence is. So suppose I have the sequence here. Again, break it up into numerator and denominator. So the first thing we'll do is look at the numerator. And yes, I see this negative, every other negative. I will deal with that in a minute. But let me just look at the straight positive numerators. 2, 8, 26, 80, 242. Well, this is not a standard pattern, but I do notice that 3 to the n, 3 to the first is 3, 3 second is 9, 3 cubed is 27, 3 to the fourth is 27 is 81. Okay, so I'm seeing that for my numerator, these are becoming 3 to the n minus 1. So these are all 1 less than the 3 to the n. Let me look at the denominator now, switch colors. Let me look at the denominator. The denominator is 1, 2, 6, 24, 120. Now when they get really big like this, you need to start thinking factorials. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 to the 6. This is looking good. 4 factorial is 24. Lo and behold, it's a factorial. So I can write the denominator as just n factorial. Now I also have these negatives in there. And I see the first term is negative, the second term is positive, the first term is negative, or the third term is negative, etc. So how do you handle it when you have a sign change? So let me switch colors again here. So for the sign change, okay, it's negative, positive, negative, positive. I can write this as negative 1 to the n. All right, so now I'm to the point of writing my entire function. My nth term is going to be negative 1 to the n, and usually put that, times the numerator, which is 3n minus 1, divided by the denominator, which is n factorial. Now, we've already done one where we look at the limit as n goes to infinity of a base to n divided by n factorial. And that's always going to go to 0, because as soon as you get higher than the base, then the terms go to 0 fairly quickly. Now, let's look at the limit as n approaches infinity of the absolute value of a sub n. All right? Because if that limit exists, and I know the limit of this entire sequence exists. So I know this is 0. Therefore, the limit as n approaches infinity of the of a sub n itself is also 0. So the sequence converges to 0.